I think it was Friday when I was explaining this type of a thing. The volume is pi r squared h. Okay, that's the volume. Okay, so the volume is pi r squared h. And try this problem. So see if you can solve it. Okay. And those of you who already solved this problem, try this type of a problem as well. Okay, this is yet another problem of that type. But for most of you, try to solve some of these problems. Okay. Yeah, try this problem. I'm not going to give you the next problem until I see more people responding. Looks like this is a slightly complicated problem here. So what are they saying, right? They're saying that if the twice the radius, right? And remember, we've done this before, twice the radius. What does it mean? If the radius, so always think about it like this. Always take these numbers to be 1 and 1, okay? Very simple. So originally, let's say you got a cylinder, right? You had a cylinder with radius 1. Radius was 1, and the height was also 1, okay? So what is the volume of this, guys? Then in that case, the volume would be pi times 1 squared, right? Radius is 1 squared times 1, right? It's going to be equal to pi, right? It's going to be equal to pi. Now try to solve this problem and see if you can understand it. So they're saying, what is the volume in cubic centimeters, right? And ignore this piece for now. Just think about it this way, right? So what is the volume in cubic centimeters with twice the radius and half the height? So what happens? You start with this radius and you now double it. That's what they're saying. Now remember, if you were to start with 1, it would become 2, right? It would become 2. The new radius would become 2. Well done, Suraj. Yes, this will become 2, and the height would become half. The height would become half, right? That's the benefit. That's the shortcut. That's the hack for this, okay? So this radius is doubled and the height is halved. So you can do this for every single problem of this type where they say, oh, this guy's halved, this guy's doubled, this guy's tripled, this guy's become 20 times. Doesn't matter. Always start with everything as 1. Everything should be 1 and then work off of it, right? So now what do? So the new volume, I'm going to call it new, is equal to, I'm just going to use this formula, guys. I'm going to use pi times 2 squared now because the new radius is 2 squared, right? And the height is half. Right? So what happened over here? Let me use a different ink, right? Let me use a different ink here. So you used 2 squared times a half, right? That's your new volume. Now, so that's going to be pi times 4. 2 squared is 4 times half, right? Now 4 times half is 2, so you're going to write down 2 pi, right? Because pi times 2, you got 2 pi, right? Now you compare this guy with this guy. Don't worry about the 22 cubic centimeters right now. Don't worry about it. That's meant to confuse you, okay? Yes, it's meant to confuse you. That's the goal of this test, right? It's meant to confuse you, but you need to know the various pieces where you can be confused and then say, oh, I know this. All the little traps, right? You should be able to jump over them. All of those traps, you should be able to jump. You should be able to identify all of those little traps, right? So yeah, so what was pi becomes 2 pi, right? What does it mean? That the volume is basically doubled, right? The volume has doubled. All of this information is just telling you the volume has doubled. So if the original volume was 22, right? If the original volume was 22, now it became 44, right? Because it doubled. That's why this is the correct answer, okay? So we're pretty much getting towards the end of the session, right? Let's try one quick problem and I'll show you a hack on that. Let's see what we can do over here. All right, try to solve this problem. Okay, it's a unit conversion problem, right? So hopefully this was a good one, right? Like, yeah, type over if you liked it, or if you like something else, let me know. Did you like the session? How was it, guys? Was it fun? Was it enjoyable? Great, thanks, Loco. Yes, thank you. Thanks, Gourmet. Thanks, CG. Yes, great. Great, thanks, Shiv. Yes, so yeah, we do these sessions. Remember, otherwise you're gonna do your problems by yourself and you're gonna get distracted, right? This way, thanks, Genevieve. Yes, so for sure, right? All of this, There's a lot of, thanks, Ben. All of these problems, right? All of these problems are, I'm gonna show you these problems. So that's in this 20-hour SAT boot camp, right? Remember, you can join anytime. The next session is going to be on Monday at 8:30, and we're going to look at the massive, this linear equations problems. Okay, this section is so important. Linear equations, it accounts for 30% of the SAT test. Thanks, Prajita. Yes, it accounts for 30%. It's got so many questions. I'm gonna explain to you every single one of them, and then we're gonna do practice sessions, right? So 1 hour of explanation, then some practice for you, then more practice for you through these kind of practice sessions, hands-on practice, and then you get more problems to practice for yourself, right? And if you want more practice tests in addition to the 10 practice tests, tell me, I've got 40 practice tests, okay? There are more tests than what's on the College Board website, okay? That's publicly available, okay? Okay, give me 1 second. So yeah, try this problem, guys. So how do you do this one? Well done, well done. So what are you going to do here? For those of you who are having difficulty, I'm going to show you a shortcut, okay? So after you're done solving, I'm going to show you a shortcut on how to think about it, okay? One, I'm going to change the ink a bit over here. Okay, so you're given, guys, you are given, I'm going to move this as well so we can have more space to talk about all of this. Okay, so remember, this was a nice hack, right? This was a shortcut, right? Anytime you're given this, you can solve this problem, right? Now I'm going to show you a shortcut for this one. Okay, you were asked 1 milligram, right? I'm just going to write it down as 1 mgm. Okay, 1 milligram. I'm just going to write it down as milli. 1 milli is equal to 2 decagram containers, right? So 2 decagram containers, right? They contain how many milligram doses? So they're basically asking you 2 decagram is how many milligrams, right? They're asking you how many millis are there in 2 decograms, right? So the shortcut for this, right? I know you can solve this. Well done, well done. All of you were able to solve this. Here's a shortcut that might help you for harder problems, okay? So all you're gonna do is you put a line over here below and put a 1 here, right? Then what do? You're gonna look at this equation over here, right? 10 grams and 1 decagram. So you multiply, right? You put in a decagram over here because you want to cancel this deca with this deca, and you put 1 deca over here, and you put, look at this equation over here, right? It's got 10 grams, okay? Right, it's already got 10 grams over here. So what's going on, guys, is you have now immediately converted this problem here. You already converted the decas to the grams because this deca goes away, right? You just got grams here. Now look at this equation. So this equation is finished, and this is an art of solving problems, right? And now you've got grams over here. So you're just gonna put a gram over here in the bottom because you want to get rid of it. And look at this, 1 gram is equal to 1,000 milligrams, right? 1,000 milligrams right over here. So what you're gonna do is you're just gonna cancel the gram out with this gram, and boom, you've got 2 times 10 times 1,000. So 2 times 10 times 1,000, right, is milligrams, right? And so that's another way to think about it. You've got 20,000 milligrams. So of course, this problem is easy, but if it ever gets confusing, don't forget this method. This is so useful if you have those complicated formulas, right? But I think you understand what's going on here. Okay, so so that's about it. I want to see if there's anything else I want to cover. I know this was supposed to be 60 minutes, but give me 1 second. There might be something I might be able to work on over here. Let me see if there's something else we can work on. Okay, I think that's about it, guys. So no, that's about it. This should be a simple problem. Remember, that could be a geometric visualization. So if you have time, try this problem. It's more like a geometric kind of thing, and then we'll close the class, okay? So we'll close the class, try this problem, but before, remember that you can join anytime, right? I'm gonna share this link again with you over here. Where is it gone now? Okay, so here's the link. All right, so you can click on this link and get the course, right? It's $95 for the entire 20 hours, right? And 1 hour has gone by so fast. And remember, these are the problems you need to know. As soon as you see this problem in the SAT, you're just gonna be able to solve it and gain points, right? So this session itself would have added 50 points, right? And remember, all of these, where are we? We are over here, right? So we are gonna move on to linear equations now. Okay, so we are going to move on to linear equations. That's a massive topic. Remember, rates and linear equations are so important, right? And then there's, of course, there's, so that's algebra, arithmetic, algebra, geometry is right over here, angles, circles, and then there's data, okay? Don't forget data. Data is super important. It's so easy with the methods I'll show you, right? People over here, they've solved the problems like crazy, okay? So easy to solve these problems, okay? So now let's look at this last problem and then let's call it a session, okay? So try this problem here. Okay. Okay, very easy problem. Don't worry about it. This is how the SAT tests are going to be, okay? Some problems are going to be hard. Some problems are going to be as easy as this, okay? Just need to read through the problem and get it. Super easy, super easy. I think many of you are getting it. Yes, some problems can be so easy as this, right? So that's a fun thing, right? Super easy. I think you understand what's going on with so much. Like, you've done the harder problems that now this problem looks like a piece of cake for you, right? It's so easy to look at this problem. So yes, we'll stay for 1 minute over here and think about this, right? So remember, many students in the past, they've boosted the score by more than 200 points, okay? You've got a dream college. You can go to your dream college just with this small investment, right? Just 95 bucks. 20 hours of your time, and you can even watch the recorded videos. You don't have to attend all of them. And if you ever miss a session, there's always going to be another session on the same topic, right? There's always going to be a practice test on the same topic. There's always going to be a practice session. It's all hands-on. You're practicing with other people, right? So this has boosted people's confidence like crazy, right? I've gotten emails by so many parents that their kids or their students are actually learning stuff, right, where they're just spending time. So you can see all of the people who've been working with me. They've been posting like crazy over here. So so again, right, just click on it. You're going to go over here and you can click over here, right? This is the website. You just buy it and then you should be inside this course over here, and things are going to work out very well. Okay, so with that, I'll close the session. All right, so with that, I'll close the session. And if you join, the next session is at 8:30. Okay, it's going to be a different link, 8:30 p.m. Eastern, Monday. Okay, that's when we are going to do a very big topic, linear equations. Okay, so thanks for your participation, folks. It was very enjoyable. Thank you so much. Thanks, Pradita. Thanks, Vidya. Thanks, all of you. Thanks, Shani. Yes, thanks, Genevieve. All right, great. All right, guys. See ya. I got to go. Bye.